So the next thing we're going to add in your tool belt for dealing with friction is we're going to start to look at these things called coefficients of friction. So we'll talk about the coefficients of static and kinetic friction. So the coefficient of static friction, it's what we call a constant of proportionality, and it's going to relate the magnitude of that maximum force of static friction and the normal force on the object. Or we'd say it's a ratio of the maximum static friction to the normal force acting on the object. Now earlier I was mentioning that the force of static friction, it doesn't have a fixed value. It goes from 0 up to some maximum value. So if you're studying force of static friction in a more formal context, you might see the force of static friction written like this. It's less than or equal to this coefficient of static friction times the normal force. But in high school, our efforts are mostly focused on finding the maximum force of static friction. So we're going to use an equality instead. We're going to say that the maximum force of static friction is equal to μs times Fn. So this letter here, this is the Greek letter mu. It's the same symbol that you would use for micro, that 10 to the minus 6. So same idea. It's kind of like a U with a little bit of a hook on the left side here. So the coefficient of kinetic friction, same idea. It is a constant of proportionality relating the magnitude of the force of kinetic friction to the magnitude of the normal force that's acting on the object. Or we could say it's a ratio of the force of kinetic friction to the normal force. So the value of the kinetic friction, the force of kinetic friction, it does not change. So we can state it's an equality. We could say the force of kinetic friction is equal to this coefficient of friction times the normal force. On the data sheet in Physics 20, they don't differentiate between static friction and kinetic friction. They just present the equation for the force of friction like this. So they have the magnitude of the force of friction equals the coefficient of friction times the normal force. All that changes, whether it's static or kinetic, is the coefficient of friction. Procedure's still the same though. So we have magnitude of the force of friction, FF, magnitude of the force of friction, and that will be in newtons. We have this mu, so this is the coefficient of friction. So I'm just going to mark here static or kinetic. And the coefficient of friction, it's what we call a dimensionless number, or it has no units. So it's just a number. So it's just a number. And then lastly, we have this magnitude of the normal force. So when we're dealing with the calculation with this formula, direction is not an issue. Like, we don't have to worry about plus and minus. This doesn't deal with the directions at all. The directions you'll get from free body diagrams and other things like that. So if we want to find the force of friction acting on an object, another way we can calculate this is having this coefficient of static friction, this coefficient of friction, whether it's static or kinetic, and multiplying it by this normal force. So up to this point, when we've been doing a lot of the force work, we haven't really looked at the vertical motion for anything on a flat surface or anything perpendicular to the plane for inclined planes. We're going to have to start to look at those things a little bit right now, or as we start to move forward in this. But this is the general equation. It works both for static or kinetic friction. The only thing that's going to change is this coefficient. So just before we get into that, just a couple of little things. So the equation for static and kinetic friction, that FF equals mu Fn, it's not actually a fundamental law of physics. These are based on approximations of experimental results. So we've kind of done a lot of experiments with different objects and having them move relative to one another. And FF equals mu Fn is sort of the best approximation we have of that. As I already mentioned, mu S and mu K, they're dimensionless, so they don't have any units. And we talked about this in the previous video. The coefficient of static friction, it's going to be greater than the coefficient of kinetic friction. I won't call it a hard rule, but a general rule that we want to use in physics is your coefficient of friction is going to be less than 1. If you start to get massive coefficients of friction, something went wrong. Same thing, it's not going to be astronomically small either. You know, if you're getting a coefficient of friction of like 10 to the minus 6, you may want to rethink your strategy on this. So the coefficients of friction between objects depends entirely on the two surfaces that are interacting. You know, there's a difference between like trying to, scooch across a thick carpet versus, moving around on ice. Ice has very little friction. A really thick carpet has significant amount of friction. It'll depend if it's wet or dry. It depends on the temperature. There's a lot of factors that affect friction.